In this video, we'll work through some of the examples and the Do Together section for lesson 4.7. So for the first example, we're going to take a look at two angles that form 90 degrees. So these are complementary angles. One of them we don't know, that's angle X here. So we don't know angle ABD, but we do know angle DBC. So because we know one of the angles and because we know that together they form 90 degrees, we can solve for x. So x is equal to 90 degrees minus 15 degrees. So x is equal to 75 degrees. And x angle is angle ABD or DBA. The second part of this example is finding two angles that form 180 degrees. So we can see that these are supplementary angles because together they form that 180 degrees on a line. So angle SQR is 100 degrees, and we don't know angle RQT. We don't know x, but we know together they form 180. So again, x is going to be equal to 180 this time, minus the angle we know, which is 100 degrees. So x, angle RQT, is equal to 80 degrees. Now we have something a little bit different. We need to find x, y, and z. We only have one angle, but what we have here is intersecting lines. So we have everything we need to be able to solve for these three missing angles. Because we understand that when angles intersect, they form vertical or opposite angles, that means that angle x is opposite and therefore equal to 100 degrees. So right away we can solve that x is equal to 100 degrees. So I'm going to label that there. But what about y and z? As we learned in our last video, when we have two adjacent angles, they form 180 degrees. So for example, y and 100, if we draw that there, we can see that those two angles form 180 because they're on a straight line. So y is equal to 180 minus 100. Those are supplementary angles. So y is equal to 80 degrees. And if we know that y is equal to 80 degrees, then its vertical or opposite angle is also equal to 80 degrees. So y is equal to 80, and opposite it, z is equal to 80 degrees. So z is also 80 degrees. And together, all four of these angles form a circle, 360 degrees. 100 plus 100 plus 80 plus 80 is 360 degrees for this intersection. What we need to do is find the value of x in the diagram, and actually we're going to find the value of y as well. This one can feel a bit overwhelming, but if we look at what we understand about angles in a triangle and angles on a line, we're going to be just fine. We can't really solve for y over here until we get x because there's not enough information for y. We know that in a triangle, all three angles equal 180 degrees, but really we need two out of the three angles to be able to find the third one. But what we have is this 55 degrees hanging out here. Why would they give us that? That's critical information right there, that 55 degrees. Because if you extend and include angle x, now we can see we have supplementary angles. These angles share a line. And now we can solve for x. X is going to be 180 degrees minus 55 degrees. And so x is going to be 125 degrees. So that 55 degrees is very important. Even though it's outside of the triangle, it's showing us that it and x together are supplementary angles. Once we know that x is 125 degrees, now we can solve for y, because y is going to be the third angle to make 180 degrees for the triangle. So y is going to be 180 minus the other two angles. Now you can do minus 125 minus 17, or you can add 125 plus 17. Both of these are fine. Probably since you're using a calculator, you would just punch in 180 minus 125 minus 17. That works just fine. But either way that you go about this, so if I just do it the way that I've set it up, it's going to be 180 minus 142. So y is going to be 38 degrees. Okay, so y here is 38 degrees. Let's take a look at the do together. We're going to identify these angles, so we're going to name the angles. There's no solving here. We're just looking at the angles and determining. So angle A here, or letter A, is 170 degrees. Remember, our reference is always that 90 degrees, so we clearly have an angle that's bigger than that. That's an obtuse angle. For B, we have an angle that's indicated outside of the little angle that we would see there, and that angle is 335 degrees. That's a huge angle. That's our reflex angle. For C, we have a small angle that's less than 90 degrees, little one, that's acute. And for D, we see that right angle 90 degree symbol. This is our right angle. Number 2 is a little bit different than what we saw in our example. So what we have here is we don't just have intersecting lines. So we can't actually say that we have vertical angles because we don't have just two lines crossing. We have more than two lines crossing. So using opposite or vertical angles won't help us here. What we know is we have a 25 degree angle, a 105 degree angle, a 90 degree angle, and then a missing angle. If we remember how this works in terms of a total, if we can draw all of the angles together to form a circle is equal to 360 degrees. So therefore, 25 plus 105 plus 90 plus our missing angle has to equal 360 degrees. And that's how we can solve for our missing angle. We can take the 360 and subtract away all the other angles. And you can show it as subtraction, so I'll just show both ways. So I'm just going to show adding the 3 that I know together. So you can show it that way, or you can show 360 minus 105 minus 25 minus 90. That's all good. Both of those methods are perfect. And when we do that subtraction, whether you add them up first or subtract them all one by one on your calculator, our missing angle is going to be 140 degrees. So now you're ready to go ahead into exercise 4.7 on the next few pages.